So the time it took to process those 5 lines of text in TCA was 9 seconds of CPU time. With multi-source solution, it was 0.9 seconds. Okay. So my name is Krzysztof Zabłocki, and Shai started us with TCA, which makes my life a little easier because I'm going to talk about how TCA works in bigger projects and the kind of problems you run into, the best practices you should be aware of. A little bit about me, I do a lot of open source. I work as a consultant, so if you are building Swift applications and you want to make your team more efficient or just have easier life developing features and be better at scaling the business, I'm the person you can hire. And what I focus on is I come into companies and I work on architecture and developer tooling to make day-to-day workflows easier for engineers. And the open source that I do is used by over 80,000 applications from Disney, Airbnb, big companies. I led the New York Times before, and I worked at the browser company before as well on the biggest TCA project. And TCA is interesting because back in 2016, I did one of the first community talks about architecture. And even though I was recommending MVVM with coordinators, I was very excited about the idea of Redux, the promise of Redux. And there was a framework called ResSwift that was the first implementation of this pattern. And I predicted that it's going to be the direction that iOS will probably go forwards. SwiftUI didn't exist back then, so we had this issue where we had imperative UI framework, but we were going into like, okay, what is the easier state management solution? And I think Point3 delivered really well with their framework of composable architecture on the whole premise of Redux and Elm. And so the pattern itself is not just based on Redux, but also Elm microarchitecture. I don't know if anyone is familiar with Elm, but basically it's unidirectional data flow. There's single source of truth, as Shai said, which is really important because most of the bugs in our applications are because there's mutable state, and so the way you synchronize state is really, really important. And TCA is very good at ergonomics and consistency across the whole code base. I like to look at this graph because I'm going to talk about a lot of issues that happen in TCA at larger scale. So for that to really reason about, you need to understand how the flow of data and actions happen in the system. So Shai showed you how to actually implement it, but this is the way it really interacts. So we have state, which is basically like, you could think about it as a snapshot when it gets fed into a view that it just rendered, right? It's a static snapshot of what the current state is. Then actions are fed from views to reducers. And a reducer, it's an object now, but you can think about it as a pure function, input, output. Inputs are state and the action, and the output is the new version of state plus side effects. So reducer is the thing that's mutating stuff. And there is environment, which are the dependencies, which you can use for the other side effects. So every kind of mutation you have to do has to come through actions. So there's a lot of action processing, which will come to bite us in the ass in later slides. So TCA framework itself, very well written, very well documented, now even more so than before. It's fully tested. It has great ergonomics, as Shai showed you. And obviously, because Point3 is a tutorial website, they go in depth, and you don't just get the framework, but you also get the reasoning and thinking behind why it works the way it works, which I think is really valuable. So if you are using TCA, I would recommend you also watch their videos to understand all the requirements and thinking that came with the framework, because there's always cons and pros to all architectures. So being able to understand why decisions were made is really important. And I collaborated with the Point3 team as I work at the browser company. So some of the improvements that I'm going to talk about already ended up in the upstream. Some of them are available in a fork that's public. My experience with TCA is I built 5 full applications with TCA, like large-scale applications. I built one for the New York Times, which got killed, unfortunately. I worked at the browser company for almost 2 years, which is the biggest TCA code base. And I consulted with a bunch of companies because as I started writing about the problems that you'll face with TCA, people started reaching out through my blog and hiring me to help their issues, solve their issues. And I also worked with Point 3 in the community to make the ergonomics better and fix a bunch of issues as well. And there's 4 areas that I want to talk about in terms of TCA, which is the stability, maintainability of our code bases, the performance of TCA and what you have to be careful there, and the kind of tooling you can build for this kind of architecture. So as Shai showed you, the default for TCA has always been exhaustive testing. And what that means is that in your test, you have to reproduce everything that your actual implementation does. So if you are scheduling timers, if you're doing any kind of side effects, any kind of mutations, you have to reproduce that in every test that actually verifies that logic. Which means that if you have a single action going into the system, you have to create a test that tests all of it, right? Which is fine for simple applications. It's not really, it actually goes against TDD best practices, because when you do a lot of testing, as I do with open source like Sorcery, you have to, like the recommendation is 1 test per assertion, so that if you have complex implementation and something breaks, you know immediately what broke and why, rather than you have to go and read the test body and analyze what the problem is. So with test-driven development, the biggest thing that I want is I want the confidence to change my implementation detail. Let's say I have an application that does like the Pomodoro timer, right? I know what the user behavior are. I could be implementing that behavior very differently in the actual internal details of the application. And as long as I have test coverage on the user stories, I should not care how the implementation details change. My test should still run. If I change something in the implementation detail, but the behavior is the same, the test should not change. If the tests change, that's fragility, and that actually means that the tests are bad, and it's an anti-pattern TDD. And it's also one of the main reasons people say that tests are not worth it, because when they wrote fragile tests, and every time they change implementation details, they have to change the test, there is no value in it, because it removes that confidence. So tests should be focused. If test fails, you immediately know what's broken, you don't analyze it. And if you have a single user action that generates 10 different side effects, I don't want to have a single test that does those 10 different iterations. I want 10 tests that each individually checks the side effect that I want to test. Because then if I make a mistake, it's usually 1 side effect that breaks, not all of them. So I immediately would know, okay, I broke Archive. So in the browser context, like if you tap one of the websites, it will do snapshots for the archive page. It will update the last active date. It will do a bunch of other side effects. And usually when we make a mistake, it will break 1 thing, not all of them. But large tests end up us having to read them over and over again and try to understand what is going on. And this is an anti-pattern called the giant. So definitely don't want to do this. So that's really what exhaustive testing did. And I wrote an article about this, and I had a talk with the Point 3 guys, like, this is really not how you want to do it. Especially, like, even here with this simple application, you had only 2 levels of nesting. And if you tested the sheet individually and then embedded into a parent reducer and want to test for that, you now have to duplicate the sheet implementation in the embedded reducer test as well. And in the larger applications, you will have multiple levels of reducer nesting. And so you won't even have like duplication of the internal implementation once. You will have it up to the depth of your tree. So if I have 10 levels of nesting and I want to have full coverage, it means that my child, like the lowest thing, will be 1 duplication, and then every embedder will have to duplicate again. So I had a lot of discussions with the team of Point 3, so Brandon and Steven, and I finally convinced them to actually not do exhaustive testing. They give us the option to do non-exhaustive version. I had an open source version that I published myself, but now it's in a fork. And the other problem with that is, like, as you saw, even Shai, like when he was writing tests, what he was looking is at the information why the test didn't fail. What happens in larger projects with exhaustive testing, people will see this failure, they will look at the logs, and the logs are great, like they did very good ergonomics there, but they will copy those messages and just paste them into tests so that the tests pass. So it removes the component of analyzing, did I actually break something or is this expected, which is another problem to have. And I originally had this like my open source version, but now it's a part of TCA because we work together to merge it off. You can easily turn off exhaustivity. There's actually multiple levels. So there's exhaustive testing, off-exhausting testing, and there's like a debug thing where it will allow you to have non-exhaustive testing, but it will warn you. I generally would prefer to turn it off because the warnings look weird and it's very stressful to me. So either choose exhaustivity or not, and my recommendation would be the same with normal programming and normal testing. If you are doing a library, do exhaustive testing, do TDD on the library. If you are building a whole app, so if you do a larger abstraction, then you probably want to do behavior-driven development. So I would do like at the leaf level, exhaustive, non-leaf level, turn off exhaustivity so that you can embed without duplicating the implementation. And that means that you will have multiple focus tests for each side effect instead of something like this. This wouldn't even fit, like the actual test was a couple hundred lines. I don't want tests that are a couple hundred lines because it's just unmaintainable in my opinion. When we talk about maintainability, tests are one thing, but the other thing is boundaries across features. So TCA does support composition, right? Like as Shai showed, it's pretty easy to embed things. The problem is, it's not the framework, it's part of the framework, but it's also the problem with the fact that we use actions which are enums, and there's no access control for enumerations. Enumeration is either fully visible or fully invisible. What that means in TCA is that if you are embedding something, you can see all the internal implementation details of those features. So all the actions that a feature do, the embedder sees, which could be a feature, like you can do cool stuff with it, like you can do higher order reducer like analytics at the top level of application and then just implement it once. But this actually becomes a big issue in bigger teams because in architectures like UDF architectures, unidirectional data flow architectures, the source of truth is not actions, it's state. But what happens is a lot of people are observing those actions as triggers to do other work, which is very gimmicky. And the default setup doesn't do any kind of nesting in TCA. Most people write actions like this, where you have convention, like for example, on did something, which is a view action. And then you have things like login results, which would be like something comes back from the side effect, like as Shai showed, like you do a network call and then you get the login results or schedule the timer, which, you know, you can pretty much tell which actions are view-driven or private here, but this is just convention and it's a very simple feature. We had at the browser, when I worked at the browser, we had action sets that were 200 actions. Trust me, it's not clear which are the view actions, which are the private actions at that point. So that's not really nice. So because the state is the source of truth, the lack of access controls causes the problem that people actually see everything and they can observe everything. As we saw, you can observe, but it's not explicit. Most people don't really model their data. They just show in like, oh, I'm just gonna add this state and I'm gonna add this state and it's gonna be fine. And it's fine for very small applications, but as you scale your team to 10, 20, 30 people or your state explodes, this becomes a big issue. So like you really want to have explicit data modeling. And you still, like even though the state is source of truth, you still want to have ability to delegate actions, right? Like as we do in normal architectures, you have delegate pattern and you have a child tell you that something happened that you need to react to. It's not always state driven and it would be overkill to try to model it as a state. So we want some kind of solution here. And for me, what I did is the first thing I did is I established a convention with actual types. So I created this protocol called feature action, which all the features in TCA would implement. And it categorized actions into 3 different sets. You have view actions, you have delegate, which is very explicit, and local actions. And that is pretty straightforward. Local is basically like the side effects, so any kind of network calls. View is what the view layer does, and the delegate is what I want the parent to be aware of. And what this looks like is that I can do this kind of implementation. I basically use protocol witness feature of Swift. So now I have explicitly grouped things. this gives me a bit of power, because if I group things together, now I can write SwiftLint rules, I can change the view layer API to have better ergonomics. And if I ever see someone trying to observe something that's not a delegate action in an embedder, I know they're looking into internal implementation details, as we established, not a thing we should be aware of. Like as we embed features, I don't want to know how it's implemented, because then I'm making it possible for me to make mistakes or misuse it. Definitely not what I want. So basically, there are things that are allowed and there are things that are disallowed. You could simply use convention, but because it's structurized, you can write SwiftLint rules for this. And at the view layer, you can create conventions that actually hide all the other actions. So now, when I'm implementing my views, I actually have better intelligence as well. So I see less actions, I see only actions that I'm meant to be using. So I can never mistakenly call something else, which is always nice. And with SwiftLint, I actually get compile time errors. So if anyone tries to be sneaky and like, oh, I'm gonna look at something other than a delegate because I know there's this action that someone pressed a button and I wanna do something with it, no, that just doesn't compile. So it makes the code base more maintainable, which is very straightforward. All of the stuff I'm talking about, I actually have articles that go in depth, so you can copy the code, you can copy the SwiftLint rules and start using it in your projects. The biggest issue and the hardest to solve in TCA, other than the boundaries, which is a big problem in larger code bases, is performance. So as you saw in the graph, every state mutation in TCA is an action. It has to be an action-centered system. And if you looked closely at the way Shai was writing the code, when he declared state, he made it equatable, but that is not actually the requirement of TCA. TCA doesn't actually require you to make your state equatable, and that has the side effect of every action that's being sent through the system has to assume that your state has mutated. There are no checks there, which means that if I'm sending a lot of actions through the system, and I'm assuming that every action causes state mutation, and I have those calls like scope, if let, all of those functions have to re-execute. So for small applications, you might have one view store, two view stores visible. For the browser, when you opened a single window, you had over 100 view stores. And 200 stores, because there's duplication for that as well. So all the projected state, all the computed properties, all of that has to re-execute. So in imperative programming, when we had high-performance code, like tight loops, you would throw in auto-release pool, you would have to optimize that. They were very sparse, right? We didn't, actually, in most projects, we didn't have a lot of places where we had to be very careful. In TCA, every scoping function is a tight loop. Every single scoping function. If you add a small sleep in one of the scoping functions, your whole application might not even launch. Because the problem is, with the vanilla TCA, with single store, what happens is, let's say, I have this app and it's working very performant and we do very quick development and we add this small feature somewhere and someone makes a mistake and they do like computationally expensive structure navigation, like a tree or list or doing some other computation. In one leaf feature, because of the way TCA is structured, this will slow down the whole application because all of those functions have to execute and all of that is single-threaded. So even a no-op action has a massive cost to your project. And what I mean by that is I did some measurements for a no-op action. So an action being sent through the system doesn't do any state mutation, doesn't do anything. For the browser, before I optimized it, it was 6 milliseconds just to send an action. Not change any UI, not do anything. Simply send an action through the system. If you want to achieve 60 frames per second, you have 16 milliseconds on normal machines. If you have promotion, you are screwed because promotion is 120, right? So 6 milliseconds for not doing anything, it's terrible. I optimized it down, I think before I left the company, I optimized it to 2.5, 3 milliseconds, depending on the architecture. For mobile projects, that's better. Arc Mobile and some of the other projects that I worked on, it's 0.2, 0.3 milliseconds, but I had clients that had performance issues on iOS even. So you have to be really careful there. There are a couple of easy wins you can apply in your projects without changing any of the architecture. For example, in TCA, a lot of the large objects rarely get mutated, but are very heavily involved in diffing. So all the view store stuff it does, it diffs the state. So what you can do is you can use copy on write semantics. You could write your own wrapper, but that makes no sense because the array type in Swift is very heavily optimized and will keep getting better. So the best thing you can do is create this wrapper that just puts your actual object into an array, a single object array. And I did this for feature flags at the browser company. And in the first minute of running the browser, we had 50,000 diffs and 0 mutations. So this cut order of magnitude of CPU time for comparing those objects. So that's a very, very straightforward thing to do. Another thing you can do, which we have in the fork of TCA in browser, is we added the ability to cut off the tree updates using diffing at a store level. So even though the vanilla TCA doesn't have requirement of equality, you can easily extend it. And we apply this on a couple of places. So at the window level, just cutting at the window level, we optimized 30% of CPU time. I applied it across other objects as well, and it added another 30% gain. So very, very useful, very simple code to do, and you can use it. It's available publicly as well. But the real gains, and not just in performance, but in maintainability of the code bases, if we go back from the vanilla TCA, from Redux, like Redux is an architecture that came out from Flux. Flux was a multi-store architecture that was simplified into a single store solution. So if we go back, it's actually much better. So one of the features that the browser had was native nodes. So I did a simple test with the vanilla TCA single store architecture versus using multi-store. So versus creating separate stores with separate state pieces. And the test was simply typing 5 lines of text into a text view. Very simple code. So the time it took, that was before the optimizations I did, but the time it took to process those 5 lines of text in TCA was 9 seconds of CPU time. With multi-store solution, it was 0.9 seconds. So still slow, but much faster. And the thing is, before this, the only way we could actually have nodes working was to add throttling at the view layer, which goes against the data consistency. And we go back to the problem where the actual data versus what the view display is not consistent. So this is a massive difference to have between multi-store and single store. And other than performance, I showed you how you can do conventions with single store, vanilla TCA, with lint, all this stuff. If you do multi-store, you can actually make your features fully black boxed. Input and outputs. Your feature only exposes the interface for configuring it and then getting a delegate back. And you can still implement those features with TCA, right? With multi-store. You can have a separate store for each feature, and you connect it through normal dependency injection. So this gives you like 100% safety, like no one is going to look at your implementation details because they simply won't be able to, because all those symbols will be private. And this also lowers your exposure to TCA. So if you scale the project and the project grows and you realize, well, TCA is really not where we want to go, like it sounded great when we were smaller, but as we grew, it became a problem. By having this black boxes, you can keep some of the features in TCA, but change your underlying architecture of your project. Or do it iteratively. Much safer, much easier, better for business, in my opinion. And you can also implement some of the features completely differently. Some features just don't work in TCA because of the performance implications, like any kind of high-frequency data processing, TCA would be terrible for, especially single store. Like if you had, like let's say you have some sensors that are sending like 60 frames per second or even higher data through the system. If you were to do that through actions and you have large application, you will be paying costs everywhere for something that is very isolated. So don't do that. Highly discouraged. The biggest con of TCA, you cannot, of multi-store TCA, you cannot do higher order reducer. Like you cannot do an analytics reducer at the top level of the application because simply you don't see the actions other than delegate. I don't think it's a big con. I think it's really not that big deal. And the other thing is forces the engineers to think about that data modeling, which again, I don't think it's a con. I think it's something that we should be doing. It's a little too easy not to do it in TCA, and in other architectures as well. But like as engineers, we try to keep things simple. But when it comes to data modeling, especially in architectures like this, it's really important. So I would say it's not a big con. Integration is pretty straightforward, especially with the new reducer protocol and dependency system. I have an article that goes over how to do it. On change, there's like a higher order reducer called on change, which lets you observe state in TCA. It's not vanilla TCA, but it's very commonly used in the community. It's very inefficient. It added 40% of CPU time for Intel machines for the browser. It's much easier to flatten it. Like the cost of reducer protocol and all the existential comparison and all this stuff is very expensive. So if you see performance issues in TCA, try to see if you can flatten it to a simple if statements, like a bunch of if statements, so much faster. And I also experimented with more aggressive changes to TCA, like creating explicit dependency trees. So a lot of the architectures from the web technologies like Relay.js and even Redux have this system called selectors, where you specify what your dependencies are to the feature, and only if those dependencies change, you actually re-execute those copying functions, all this stuff. TCA doesn't do that, as I explained before, but I actually had a fork where I did it explicitly. I would say at this point, you're no longer using TCA, so is it worth it? I think like the added complexity kills the benefits. I think there are other architecture approaches you could do. So I have an experiment. If someone is interested, I can show it in the future. But generally, I would say probably not want to do it. Memoization also not something that I found useful. I have an article where I memoize state so that I basically created an external cache to TCA. And that works, but the fragility of this kind of solutions, I generally think that an architecture has to work. It has to be reliable. So this kind of experimental stuff is interesting just from an engineering perspective. But if you cannot fully automate it, that it's going to be reliable every time, you could have cache misses, stuff like that. Don't do it. Highly discouraged, because finding those bugs is really hard. One of the big benefits of TCA and how I actually, as I developed this stuff for clients, I had to build a lot of tools, because the biggest promise of TCA, of even unidirectional data flow, is, and that's a really big sell to engineers, you will be able to understand what's going on in your application, right? That's the biggest promise. I really want to know what is happening. Unfortunately, that is actually not the case in larger code bases, because once your state starts growing very heavily, you have so many side effects. There's so many things happening, so many nestings of reducers, that it's really hard to reason what's going on in the application. So to be able to do that, I built a bunch of tools that let me track this stuff. And with tools, you can do it, but with the vanilla implementation, it's really hard to follow. So one of the tools that I built is a performance dashboard. So it tracks the cost of different phases of TCA, so the amount it takes to scope those substates, the quality costs, the propagation of actions. So on the left, you can see all the individual costs attributed to specific stores, so I can find which stores are expensive. On the right, I built a store tree, so I can see how my application is structured. This is really important for bigger applications. In iOS, you usually have one active screen, so it's pretty straightforward to understand how it happens. But on Mac apps, you have multiple windows, you have a lot of nested components, and so being able to see the tree of how the actual state is being configured is very useful. The nice thing about TCA, because if you have consistent architecture, building tooling is straightforward, so building those tools was not hard. The other tool that I built is something that Shai showed was the print changes. So I built a visual version of this where you can actually filter actions, because in larger applications, you will have a lot of actions that are noise generators. Like for Mac apps, for example, you can have hover as an action. You can have the window that activate, all those actions. There's a lot of noise. You don't really want to look at that most of the time. So I built this spy dashboard. I'm going to write an open source version of this now that I'm no longer bound to a company. So I'm going to make an iOS and Mac cross-platform solution for this, so everyone will be able to use it. You can watch my blog, subscribe to my blog, you'll get access to it. This is very convenient. This helped us find a lot of weird things. The green actions here are no-op actions, are actions that have been sent to the system but didn't actually mutate state. And if you select one of the red ones, it will actually show you the same div that Shai showed you with the print changes. The nice thing about this is this costs nothing, so you can have it in production application and you can have a hidden way to show it. And then it's just an if statement, and it shows this window. And you can, if you have a client that says that the app is misbehaving and it's very slow, you could send them a URL, that, like a dip link URL that activates this window, and you could see what kind of actions are going through the system. So you can find like timers that are running off while, stuff like that. And the other thing is, one of the things I built is I built a custom lifetime tracker for the browser, and I connected TCA through it. So you can see here how many view stores and stores are alive when we just launched the application. And what's really nice about this, other than being able to just know how many there are, is because if you have this consistent architecture that those objects exist everywhere, you don't actually have to integrate lifetime tracker in many places. You can just simply add it at the architecture level, and now I close the window, and if those things are still alive, I have leaks. So it immediately tells me, oh, I'm actually leaking memory all over the place. So it's really powerful to be able to build tools with consistent architecture, and it's really convenient to, well, it's really convenient, but it's also necessary to have those kind of tooling, because it's really hard to reason in larger code bases what's going on. And in summary, I think that the composable architecture framework itself is really well written, very well done. I don't think it scales very well for larger applications, so be careful there. But if you like it, I would highly recommend using multi-store. I'm not the only person using that. Like the Ramp company that does the credit cards, they also do multi-store TCA from the beginning, and they're very happy with it because it has very clear boundaries, better performance, less business risk. So I highly recommend, if you do TCA, consider multi-store. It's a lot easier to start with this than to refactor existing application into using multi-store, because refactoring requires you to remodel your whole data, which is a pain in the ass. So start fresh, be aware of those problems. I'm available for consulting if anyone needs help with either TCA or any kind of architectures. I often get hired to audit the whole code bases and find practical solutions to improve development for the whole team. And you can follow me on Twitter or GitHub. I write at Borrowing Info. I write a lot of articles, and thank you.